Hello, wonderful mathematicians. This is Mr. Garcia, and today's lesson 3.7. It's not really anything new. We're continuing the practice that we were doing on 3.6 with writing proofs and solving equations involving angle relationships. And so you have 4 additional problems for extra practice that you can complete in the same way that we did it last time. So you have your equation, you're going to set it up either being equal to each other if they are congruent, or adding up to 180 if they are supplementary. And you will need your 3.5 notes and your 3.4 notes to help you with the angle relationships as well as with the justifications for your proofs. So what I want to show in this video, last time in the last lesson video, and you can watch that 3.6 video if you need to, we talked about how to solve when we have angles that are congruent. For example, here I have a pair of corresponding angles, and according to my notes, corresponding angles, let me zoom in here, corresponding angles are congruent. Or if you didn't know that they were corresponding, you can use the notes, not this one, you can use the notes to find out what type of angle relationship they are. In this video, I want to go over an example that have supplementary angles because we didn't really talk about that in the last one. So I'm going to jump down to number 3. Number 3 says, given the diagram below, find the value of x. And let me zoom in here to see it a little better. And so I have 13x plus 37 for one side of, or one of my angles, and 7x plus 43 for the other. And so what I want to see is, well, what type of relationship do these angles have? Well, first, I need to remember that in between the two parallel lines, and I can tell these lines are parallel because they have a little triangle on them. That little triangle means that they are parallel. So I know that in my parallel lines, I have the interior region between the parallel lines and the exterior region outside the parallel lines. And if I look, both of the angles that I have information for are on the outside of the parallel lines. So that means that these are exterior angles. If I look at my relationships, I have two options when it comes to exterior: alternate exterior or consecutive exterior. Let's look at the difference between them. Alternate interior, angles that are outside, we know that, and on opposite sides of the transversal, while consecutive exterior are on the same side of the transversal. So let's find our transversal. See, we have the parallel lines here, so this must be our transversal. And if we look, both of our angles are on the top side of my transversal. So these are same side interior angles, otherwise known as consecutive interior angles, and we know that they are supplementary. So with this information, we can begin our proof. So always, remember my first justification is always given. And what am I given? According to the question, given the diagram below, I'm given the diagram. So I'm going to write diagram here. I'm going to add another row. You can right click and then insert row below. And we said that these two are consecutive exterior angles. So we can put that down as our justification because that's what we're going to use for writing out the equation. Remember, our step now is to write out the equation. So we know consecutive exterior angles are supplementary. So now the question becomes, what is my equation? How am I going to write it here since they're not equal to each other? Being congruent, they would be, but they are not in this case. So remember that two angles that are supplementary add up to 180 degrees. So if I have, for example, angle A, and I'm just going to insert this so you guys can see what I'm talking about. I'm going to insert an angle symbol. That's not the angle, that's the angle. So let's say that the measure of angle A plus the measure, I'm going to copy this angle symbol, the measure of angle B, I add them together and that should equal 180 degrees, right? Well, let's say that this 13x plus 37, that's the measure of angle A. Let's say that. And let's say that the measure of angle B is this 7x plus 43. If I know that adding the measure of these two angles equals 180 degrees, then I just need to know what the measures are. Now, obviously, I don't know what they are as a number, but I know what they are as an expression. And so all I can do is plug this in, the 13x plus 37, to the measure of angle A. So this is what it's going to look like. 13x plus 37. You see how I replace measure of angle A with whatever I have for the measure of my first angle, 13x plus 37. And I can do the same thing with the measure of angle B. Here my angle B that I call B is 7x plus 43. So this measure of angle B, I'm going to replace that with 7x plus 43. And so now I have my equation. And now I can continue with solving this equation. So when I have my equation, remember the goal is to get x by itself. So I'm going to look for x terms on both sides of the equation. So I look on the left-hand side only, and yes, I have x's. I look on the right-hand side, there's no x. So I don't need to move any x's around. But you did notice that I have two x's, but they're both on the left-hand side, right? So when I have those two x's, remember, we need to combine like terms. So we're going to combine these two. 13x is positive, 7x is positive, so I'm just going to add them together. 13x plus 7x, 13 plus 7 gives me 20, and I put the x back in. Then I have plus 37, I didn't touch that, I leave that alone. Oops. Plus 37, plus 43, again, I didn't touch that, I leave that alone, equals 180. Again, I leave that alone, didn't touch that. And what's my reasoning here? Well, what did I do? I combined like terms, right? So that's going to be my reasoning here. Combine like terms. And you can also abbreviate it CLT, just so you don't have to type out combine like terms. All right, so let's continue. I'm going to add another row. And I can also combine these two, right? Because they are also like terms, and they're both on the same side of the equation. Since they're both positive, I'm going to add both of them together as well. So I bring down my 20x, I didn't touch that. And then I have plus, let's see, 37 plus 43, 7 plus 3 is 10. Carry the 1, 4 plus 3 plus 1 is 8. So there should be 80 degrees. I'm just going to double check my math. Yep, 80 degrees. And then equals 180. And again, I combined like terms, right? That's all I did here. So combine like terms. Continuing on, now our equation looks a little more familiar, right? So it gets a little bit easier after this point. Let's see. We need the x's on one side isolated. This plus 80 is in the way. We need to get rid of it. So we're going to cancel out plus 80. How do we cancel out plus 80? The opposite of positive, the opposite of plus is minus. So I'm going to do the inverse, the opposite operation, and subtract 80 from both sides. So 20x stays there. And since I canceled out the plus 80, that's not there anymore. After that is the equal sign. Now 180 minus 80 is 100. And so this is where our equation is at so far. What's our reasoning here? Since we subtracted to cancel out the 80, This is the additive inverse. And I'm going to put parentheses minus 80 since we subtracted 80. Let me add another row. And what am I going to do now? I need to get x by itself. The 20 is in the way now. But remember, 20x means 20 times x. So if I multiply here, then to cancel out multiplication, the opposite of that is to divide. So I'm going to divide both sides by 20. 20x divided by 20 is x, just x. 100 divided by 20 is going to be 5. Let me change that back to a lowercase x. 100 divided by 20, like we said, is 5. And here, what we did is the multiplicative inverse, where we divide by 20. And my x is equal to 5. And that's it. I'm done. There's nothing else that I need to do here. I know what my value of x is. I can double check it, plug it into our equation, our expressions here, and see if they add up to 180. Or just plug it into our starting equation, see if the left-hand side is equal to 180. So I'll let you guys check that on your own. Now the rest of these proofs are just like what we've already done, so I'm not going to talk about those. If you need help with those, you can see Miss Caddy's video on lesson 3.6 where she went over those. What I'm going to do instead now is talk about the other assignment that you can do for today for 3.7. This assignment is called Transversal Town. The story here is that you are working as an assistant to the new city manager in your city. They lost part of the plans for the city and they need your help to refill the list of the angle measures at each intersection of each street. So what you're looking at is a map of a street map of Transversal Town. And the city planners, we do need to know the angles, right? When we plan out streets to make sure that it's wide enough to accommodate maybe some post offices or stores or whatever buildings we're going to have there. But they lost those. And we only have 3 that are known. Or 4, actually. Sorry, I missed this one. So we only have 4 that are known. And we need to use these 4 to find the rest of them. So you can start this off whichever way you want, but what I would recommend is to start by identifying these angles first. And you can use a text box if you want. In fact, I'm going to zoom in a little bit more here so I can see, well, it's not that much more, but it's good enough. And you can use a text box. And for example, number 1, the angle measure is 112. And I can make that small, not that small, so that it fits in there. And since I know that that angle is 112, I can use that to start off and find everything else, all the other angles, using my angle relationships. So for example, immediately after this, let's see, I guess the easiest way to start this would be for to find the angles around the 112. Well, if you look at angle 6, angle 1 and angle 6 are adjacent to each other. They're right next to each other. And they have that straight line here, right? Remember, that straight line means a linear pair. And according to our notes, a linear pair up here at the top are supplementary. They add up to 180. So since I know that, since I know they add up to 180, I can subtract 112 from 180 to find what angle 6 is, which I don't know off the top of my head. Sorry, guys. It's been a long day. Let me do that math real quick, and you can use your calculator. You can use Desmos here if you want to make your life easier. I just like to complicate mine unnecessarily. But it turns out that 180 minus 112 is 68 degrees. So this angle 6 would be 68 degrees. So I'm going to type in 68 for angle 6. Now, I also want to justify, what did I do? Well, I can write linear pair. So now that I know angle 6, I can fill it in too if it helps you visualize it. You don't have to. I would recommend it though, so that you can see them. And so let's see. Now after these, I do have the two parallel lines going here, right? Those triangles means that these two lines are parallel. I have another one way over here. So that means that if 1 and 6 are 112 and 68, then by corresponding angles, because remember, corresponding means I just copy one set of angles to the other intersection, and that's what I have here. 1 and 6 correspond to 3 and 8. So I already know that angle 3 should be 112 because corresponding angles are congruent. So I can leave that as corresponding, or you can write corresponding angles are congruent. And we said that angle 8 should be 68 for the same reason. So I'll write 68 here, and I'll copy that, and I'll paste it down here. Now, because this line way over here on the right-hand side is also parallel to these, then that means 1 and 6 are also congruent to 5 and 10, respectively. So 5 and 10 would also be 112 and 68. And when you get down here, you're also going to have another angle that's going to help you start off. For example, here, angle 15 is 52, and knowing that, 22 I know would be congruent because they are vertical angles. So knowing that 15 and 22 are congruent because of vertical angles, I know that 22 would be also 52 degrees. And I can put vertical angle with 15. And here maybe I can put corresponding angles with 1 instead of are congruent, so that I identify which other angle forms that pair. So here corresponding, we said angle 8, corresponding angles with 6, and so on. Alright guys, and that's pretty much it. That's how you do this one. It does look like a lot of angles. But remember, most of these are either going to be congruent, and if they're not congruent, then they're supplementary. So use that to help you out here. And if you have any questions, let me know. I will help you as soon as I can. Alright guys, so that's it for this lesson. Like I said, make sure that you finish either one of these, I'll take it. Or if you finish both of them, that's extra credit. Alright guys, so have fun, stay safe, and I'll see you guys next time.